Okay, so I was asked to do a video on nodal analysis, so I thought I would do this with one of the questions from the midterm. Okay, so the premise of nodal analysis is that if you have a straight wire or a bunch of wires that doesn't have any resistor or voltage source or current source on it, then it would maintain the same voltage all along. So basically what you need to do when you identify all the nodes is that you find each segments of wires that are not obstructed or like blocked by anything. So in this graph we have the one on the ground and this one, this one, and the last two. Okay, after you identify each of the nodes, you would have to do analysis on them and abstract some important informations based on the voltage sources. So in this graph, we have two voltage sources. One of them is connected between two nodes that are neither of which are ground nodes, and one of them is between a random node and a ground node. So we sort of deal with them differently when we do analysis on this. So if a node is directly connected to a ground node with a voltage source in between, then we can immediately deduce that node has a voltage that's equal to the voltage source. So here it's 3V naught. And if two nodes are connected by a voltage source, but neither of which are ground nodes, then we can only say the difference between them is the voltage source. So here, if I label this as V2, this as V3, I would have V2 minus V3 equals to 2. And the way we deal with these kinds of voltage sources is that we have to combine both of these nodes into a supernode when we do nodal analysis. Because if we don't, we would have to redefine a new variable, which is here, we have to call it like I1 or something. This is because we really don't know the voltage flow through the current flow through a voltage source. So yeah. Okay, so let's find the remaining information. So we recognize that we also have a dependent source, which is dependent on V naught. And V naught is the voltage on the 3 ohm resistor. So we know that this node, if we call it V1, has the voltage of V naught. Okay, so if I write that down here, um, then we already collected all of the sources information available to us about the voltage source and the dependent voltage. Okay, so the next thing to do is nodal analysis. So we already analyzed, we sort of already did analysis on the node on the right corner, just because we know its voltage from the voltage source. So we don't really have to do a nodal analysis on it. The next node I want to do is here, V1. I know that V1 equals to V2, but I still have to do nodal analysis and calculate the required information. So here, node 1. I can customize define the direction of current flow. So in this way, in the way that I'm defining it right now, both currents are exiting, so they will be on the same side. I would write the difference between V1 and the ground node, which is V0, over 3, plus the difference between V1 and V2, which is the voltage through the 5 ohm resistor, which is V0 minus V2 over 5 equals to 0. And let's see, node 3. Right, so when we talked about the voltage source between two nodes, neither of which are ground nodes, we know that we have to combine them and analyze the supernode. So here I have a current entering, a current exiting here, and a current, let's just say exiting. Okay, So we have the current entering equals to V naught minus V2 over 5 equals to the exiting, which is V naught minus 3V of V2 minus 3V naught over 3 plus, oh, we do have to look at the current here. They are actually the same thing. No. Okay, so here it is V3 minus the ground node, which has the voltage of 0 over 10. So yeah, we have analyzed all of the required information. Now let's check if we have enough information to solve the equations. So we have the number of unknowns are V naught, V1, V2, and V3. These are 4 unknowns, and we have 4 equations. Here, 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 and here. You can actually just say we have 3 equations really, because V1 just equals to V naught. That's not necessarily something you need a computer to solve for. Midterm, it doesn't really ask you to solve the matrix just because it's not testing you on the math skills. And so this would actually be the end of the question. So just a review, the process to do nodal analysis. First, label all the nodes. Nodes are just a bunch of wires which doesn't have any blockage between them. Second, you write down all the equations for the dependent and independent voltage sources, which is what we did here. And third, you write KCL for the remaining nodes. This is just the exiting and entering current would adds up to 0. And you see if a voltage source is between 2 nodes, neither of which are ground nodes, then you have to do a supernode between them, which is what we did with node 2 and node 3. And finally, just check for the number of unknowns and equations and solve the matrix or not if you're doing an exam instead of a web work question. Okay. I will probably do a opera amp video later. So yeah, till next time.